No, I think it's muted. Okay. So let's repeat the example we have seen before. So this is the summation for Z transform. X of Z is summation of x of n times some new variable you see here, z the power of minus n, which is a complex frequency. R is the magnitude, and this is the frequency, complex frequency part. So this particular example, let's take first example 1. Let's take discrete time signal x of n, which is samples 2, -3, -1, and 4. Okay, so this is the arrow, and we are taking consider z is equal to 1 only. 1 means this part is 1, r is equal to 1. Okay, so it is DC. This is what it is, a DC signal. Now z is 1, so z to the power of minus n. Here you see z to the power of minus n. So if z is 1, it will be 1. So it's a DC signal with amplitude 1. Here you see z can be a complex variable, r times e raised to j omega. So e raised to j omega from Euler's relation, this part, e raised to j omega can be cos omega minus j sin omega, sinusoidal, right? R is the amplitude. So the Z, you can take Z, different type of Z. It can be sinusoidal, it can be exponential, it can be decreasing oscillation, increasing oscillation. Z, okay? Z is general complex variable, different types, okay? Different types. Compare this with what? With x of n, correlation we call it, okay? Why we need to do this correlation and convert x of n to x of z? This signal, is it sinusoidal inside? What type of sinusoidal? What type of exponential? What type of oscillation, decreasing or increasing oscillation inside x of n? You can determine by using Z transform. So in this particular case, we take what? We take Z only 1. Okay, Z is a variable, not sinusoidal, not exponential. We take Z1 constant. Okay, 1 is discrete, 1, 1, 1. Okay, so now let's correlate this Z with X using what? X of Z formula, Z transform. So what we have to do? First, multiply these two, right? X of n with Z, multiply. So 2 times 1, it will be 2. 3 times 1, minus 3. First, multiplication of x of n, z to the power of n. Next value, minus 1 times 1, it will be 1. Minus 1, sorry. Then 4 times 1, it will be positive 4. After that, on the formula you see, it is, you have to add, multiply each x of n with z, then take the summation. That's Z transform means. So when you add this, what do you get? Here, minus 1 plus 1. Am I right? So this is minus 1. So minus 1 times 1 is minus 1. Okay. So it will be 2. Okay. Now let's take another signal. as I said, another signal x of n with samples 3, minus 3, again 3, and minus 3. Here is the arrow. Okay. Now let's do correlation. Let's transform this x of n into x of z by taking only what? By taking z is equal to 1. Z is equal to 1 means you can see from this z when it is 1 means omega must be what? 0. Okay. E raised to j omega will be 0. R is equal to 1. In this case, Z will be 1, which is only for DC. Now I am correlated, find similarity, find DC component inside my signal. Okay, let's correlate second signal, second example with Z is equal to, when Z is equal to 1, what is here? Z the power of minus n, the formula. So Z the power of minus n, it will be what? It will be all 1. 1, 1, 1, 1. Okay, sorry. Now, correlation between these two, x of n and Z the power of minus n. In the formula, what is Z transform? Multiply x of n by Z the power of minus n multiplication. So multiply 3 times 1, 3. Minus 3 times 1, minus 3. 3, positive 3 times 1, 3. I am multiplying. Then finally minus 3 times 1, minus 3. After that, in the formula, you have to take what? Summation n start from 0. Here, how many samples? 4. So n starts from 0 up to 3. Take summation. What will be the result? The result is 0. So the first case we get 2 values. Second case we get 0. So there is a strong correlation of this signal, the first signal, with DC. Correlation means similarity. Because we get what? Similarity 2. So inside this signal, there is what? There is one component, a DC component. But the second part, we get what? We get 0 correlation. Correlation between x of n and Z the power of minus n, which is a DC. Correlation 0, similarity 0 means inside this signal there is no DC, right? You can see here, if you plot it, this sequence, if you plot it, first amplitude is 3, second amplitude is minus 3. So what is average? 3 plus 3 divided by 2, 0. Just like a sinusoidal. If you have sinusoidal signal like this one, what is average? What, is there any DC here? No. Positive equal with negative. So if you add this, they will cancel. There is no DC. The DC's average is 0 here. Similarly here, equal positive, equal negative. If you take the average, it will be 0. That's why inside this signal, there is no DC component. Z transform tells you not only for DC component, you can go for what? Check your sinusoidal with your signal. Check exponentials. This is exponential, sorry. Exponential with correlate with x of n. Calculate what? Find x of z. X of z, what we call it? Z transform. Okay. So Z transform, very powerful tool in digital signal processing. It will tell us. The presence of sinusoidal, decreasing oscillation, increasing oscillation, exponential, what type of signal exists in your sample x of n, you can determine by using z transform. Use this formula, convert x of n to x of z. Now you have a detailed information about your signal. Is there any damped oscillation? What is the frequency? What is the phase information? All this information you get from the Z transform. Okay. So what is Z? Z can be a DC. You see here, when Z is equal to 1, e raised to 0 means what? Frequency is equal to 0. So it is DC sample. Okay, these are samples. Don't take that. So this is a few examples of Z to the power of minus 8. How about here? Z is equal to how much? 0.9 e raised to jx. So it's complex. The frequency j pi, sorry, pi. So frequency is pi, omega is pi here. What is amplitude? Amplitude 0.9, and it is increasing. So this is one other example of Z. Here is another example of Z. What type of Z is this? Decreasing exponential. Here what is Z? Decreasing sinusoidal. Z can be a complex frequency, different types, DC and so on. So by doing this Z transform with x of n, multiply it and take summation, convert x of n to x of z means what? What is the relationship between your signal, our signal, with DC? Is there any DC in your signal? What is the relationship or correlation x of n with this such type of signals? What's the correlation with exponential? What's the correlation with damped oscillations? All this we get it from Z transform.